Hey everyone, and welcome. If you're just using JavaScript arrays to, well, store data, you're really only scratching the surface of what they can do. Today, we're going to open up the full developer's toolbox and learn how to actively manipulate, transform, and truly master your data with some of JavaScript's most powerful array methods. So, you've got your data, right? It's all sitting there, nice and neat, inside an array. But here's the thing. An array isn't just a static list. It's a living, breathing structure. The real question is, what are you going to do with it? How do you pull out the exact information you actually need? So here's our game plan for today. We're going to start with the absolute fundamentals, adding and removing items. Then we'll level up to finding and filtering data. From there, we'll get to the really powerful stuff, transforming arrays, tackling the mighty reduce method, and we'll wrap it all up with a rapid-fire cheat sheet so you walk away armed with as many tools as we can possibly fit. First up, the operations you'll probably use every single day, just getting items into and out of your array. Now, these might seem basic, but they introduce a really important idea you have to get your head around: the difference between changing your original array and creating a brand new one. And that brings us to a classic point of confusion: slice versus splice. They sound almost identical, but trust me, they're polar opposites in one critical way. Slice is the safe one. It just takes a copy of a section, leaving your original data completely untouched. Splice, on the other hand, is a bit of a brute. It directly changes or mutates the original array. It can add, remove, or replace items right in place. So, the big takeaway? Be super careful with splice. There's a reason we call splice the Swiss Army knife of array methods. It does pretty much everything. It's so flexible. The first number you give it tells it where to start making a change. The second one tells it how many items you want to delete, and then anything you add after that gets inserted right into that spot. It's incredibly powerful for making really precise edits. Okay, so we know how to add and remove things, but most of the time our arrays are full of data, and we need to find specific things. So our next set of tools is all about locating and pulling out the exact information we're looking for. So for a simple check, is this thing in my array, you've got two main options: index of and includes. Index of is older. It'll give you the numeric position of an item, or a -1 if it's not there. Includes is more modern and honestly usually more useful. It just gives you a straight up true or false. But here's the real kicker. Includes correctly handles NaN, or not a number, while includes just fails. That little detail can save you from some really tricky bugs down the road. But what if you're working with an array of objects, not just simple numbers or strings? How do you find a user with a specific ID? Well, that's where find comes in and saves the day. You just give it a little function that describes what you're looking for, and it will scan through the array and return the very first item that matches your condition. So useful. Now, find is great when you just need the first match. But what if you need all of them? Say, all the users who are over 18. Well, that is exactly what filter was made for. It works just like find, but instead of stopping at the first match, it keeps on going and gives you back a brand new array with every single element that passed your test. Okay, now we're getting to the really cool stuff. These next methods, they don't just find things or make small changes. They let you transform your array into something completely new. This is where you can really start to build some powerful and elegant data pipelines. Let's talk about map. The map method is an absolute workhorse. It lets you create a new array by running a function on every single element in your original one. So here, for example, we're taking an array of names and, just like that, transforming it into an array of their lengths. The key thing to remember is that the new array you get back will always have the exact same number of items as the one you started with. Alright, let's talk about sorting. Seems simple enough, right? We've got an array here with a few numbers in it, and we just call the .sort method. So just take a second here and think. What do you expect that array to look like after we sort it? I mean, logically, it should be 1, then 2, then 15. But is that what JavaScript is going to give us? And there it is, 1, 15, 2. What? This is a classic JavaScript gotcha that gets everyone, and I mean everyone, at some point. The order is just completely wrong. So what on earth is going on here? Well, here's the secret. By default, JavaScript's sort method doesn't look at numbers as numbers. It converts everything to a string first, and then it compares them. And in the world of strings, like in a dictionary, 15 comes before 2, simply because the character 1 comes before the character 2. It's a dictionary style sort, not a numerical one. Thankfully, the fix for this is surprisingly simple and elegant. All you have to do is give sort a little hint, a compare function, to tell it how to sort properly. This tiny arrow function here, a comma b, a minus b, tells sort to just treat the items as numbers and subtract them, which gives us the correct numerical order every single time. It's a lifesaver. All right, it's time for our final deep dive. Let's talk about the reduce method. This is easily one of the most powerful, most versatile tools in the entire JavaScript toolbox, but it can also be the most intimidating at first. So let's break it down together. So what is reduce for? At its heart, it's designed to take a whole array full of stuff and boil it down to just a single value. Now, that single value could be something simple, like the sum of all the numbers, or it could be something much more complex, like a brand new object you build up piece by piece. The magic is that it iterates through the array while carrying a value along from one step to the next. And this table shows exactly how that works. That value it carries along is called the accumulator. Let's watch it. In the first step, the accumulator starts at our initial value, which is 0. It adds the current item, 1, and the result, 1, becomes the new accumulator for the next step. Then it takes that 1 and adds the next item, 2, to get 3. This just keeps going until it's visited every item, and we're left with our single final value. Alright, we've gone deep on some of the heavy hitters. Now, as promised, let's switch into rapid fire mode for a cheat sheet of other essential methods to really complete your toolkit. We're going to cover as many as we can right now. Okay, for adding and removing, you've got push and pop for the end of the array. You've got shift and unshift for the beginning. We've talked about splice for modifying things anywhere, and slice for making a nice, clean copy. And finally, concat, which lets you merge two or more arrays together into a new one. And for searching and transforming, use index of or the better includes for simple checks. Use find or filter for more complex function-based searches. And to transform your data, you've got the big ones. Map to create a new array of the same length, sort and reverse to reorder it in place, and of course, the ultimate power tool, reduce, to boil it all down to one single value. So I want to leave you with this thought. Stop thinking of your arrays as just static lists of data. Start seeing them as a fluid stream, a stream that you can shape and direct. You can chain these methods together, piping the output of a filter into a map and then into a reduce to build exactly the result you need, elegantly and powerfully. That's where the real magic happens. Thanks for tuning in.